Hello, everybody, and welcome back to another exciting edition of Finance. We're going to be looking at in this handout, which is handout 11b, discounted cash flow valuation methods under mutual exclusivity or rationing. So let's jump right into it. So far, when we've been doing our DCF valuations, we've been assuming that our projects have been independent here and also that our budgets have been completely unlimited. So that's fine. But now I want to look at some different assumptions and see what follows from them. So let's move on to mutually exclusive projects. And mutually exclusive projects is just going to mean that if we decide to pursue project A, then we're not going to be able to pursue project B. So we say projects A and B are mutually exclusive, plain enough. Let's look at some examples here. So one example is getting to work. We could walk to work or we could drive to work. That's assuming we are going to work, which many of us are not doing right now and may not be doing for a while, sitting here in March 2020. If we have a gorge with room for just one bridge and we want to build a bridge across that gorge, we could choose to make a suspension bridge or an arched bridge, but there's only room for one bridge, and so we couldn't do both. So what we want to do is decide which alternative is best here, and let's consider doing this with unlimited budgets for now. We'll start constraining our budget soon enough. So the particular type of mutually exclusive projects that I want us to focus on are what's called mutually exclusive equal length projects. So as usual, we have a definition. What do you do when you get those definitions? Memorize those babies, right? Okay, so we've got here mutually exclusive equal length projects called throughout finance MEEL projects for short. These are projects that start at the same time. Okay, so let's just make that clear. Start at the same time, okay, and involve cash flows going forward for the same number of years, or we could say same amount of time. Okay, so let's look at some examples. So here would be two projects we could look at. One would be a 10-year zero coupon bond versus, on the other hand, a 10-year annual pay bond. So with this bond, definitely there's only two cash flows, one at t equals 0 and one at end of year 10. And this bond is going to have cash flows every year from t equals 0 when you purchase the bond out to t equal 10. And that's the key. They both end at t equal 10. They both go out for the same number of years, the same amount of time, and they're both starting today, okay, at t equal 0. So what we want to do is we're going to be looking at two projects, maybe three projects sometimes, and we want to decide which one is best for us of these mutually exclusive equal length projects. And what I'm here to tell you and to prove to you in the next couple slides is that the correct answer is always the project with the bigger net present value, the project with the bigger NPV. And interestingly enough, as we're about to see, if you use the BCR method or the IRR method, you may get the wrong answer. And depending on how big the project and the consequences, that may lead to horrible things, that may lead to people getting in big trouble, to you getting fired, all of a sudden you're selling apples out of an apple cart in the town square, and that's not good. So we want to have you avoid that, so let's see how we can do that. Okay, so why do IRR and BCR sometimes give the wrong answer? A good way to think about this and to illustrate this is to consider two equal risk, mutually exclusive equal length projects, and let's say they both have their equal risk, both have the same opportunity cost of capital of 10%. So for A, we could invest $10 today and get $20 back in a year. And for B, we could invest $100 today and get $150 back in a year. So we want to know, if we have an unlimited budget, which one should we pursue? Remember, we have an unlimited budget, but we can only choose one of these two projects. We can do other projects with our unlimited budgets, but as far as these two are concerned, we've got to pick one or the other. So let's think about this a little bit. If we do a BCR analysis of A, we've got this cash flow. This would be our CF1, and this would be our CF0, and then we're going to discount CF1 by 10%, right? So let's get our BCR. So our BCR for A is going to be 20, let me put this in parentheses, 20 divided by 1.1, that's 1 plus RR of 10%, and let's see what else we've got here. Okay, we've got to divide that by our minus 10, and we take the absolute value of that. So that's our BCR formula, and you should check that if you do this, you get 1.8, right? Check this. Please check this, okay? All right, and now we do the same thing for B. Our cash flow one for B is 150, so we want that over, discount that by 1 year at 10%, and let's do, let's divide that by, what do we want in the denominator for our BCR here? We want our minus 100, okay? And if I work that out, I get 1.36, and you should check this. This is the best way to understand what's going on in the homeworks, the best way to start studying for exam 2. Everything we do in class, just see if you can do it from scratch and get the same answers. Okay, so which one looks better? Definitely project A. And what do we say for BCR? What we always say for BCR is project A has more bang for your buck, right? Okay, so doing a BCR analysis of these two, we would conclude, not unreasonably, that we should go with A. All right, and let me just pause here for a second. Okay, now we are back in action. So let's do the same type of analysis with IRR. So remember, the IRR is, we just want to write down our NPV equation, right, and set it to 0. So NPV equals 0, and that's equal to, for A, we have the minus 10 plus, we have our 20 over 1 plus IRR to the what? This is a 1-year project, okay? And so our IRR is going to be, if you work out the math on that, 20 divided by 10, minus 1, and that's equal to 100%. Pretty awesome IRR there. So IRR equals 100%. Okay, so we're not sure what to go with yet. So I think who typed that? I'm going to blame that on the TAs, right? Always good to blame things on the TAs when you can. We can't say what to go with yet because we have to compare this to B. Okay, so we do the same thing for B, right? To get the IRR, you just write the NPV equation, set it to 0, and solve for that IRR that makes it the truth, the whole truth, and nothing but the truth. So in this case, we have minus 100 plus our cash flow 1 is 150, and we divide that by 1 plus IRR raised to the 1 because it's a 1-year project. So we can solve that for IRR is equal to 150 over 100 minus 1, and that's equal to 50%. Okay, so we put in our 50% down here for B, so we clearly would want to, doing our IRR analysis here, we clearly want to go with A. So now, finally, let's do an NPV analysis of these two and see what kind of conclusion we come up with. So for A, all we're doing, remember with the NPV method, it's the simplest method, right? Every stinking cash flow, discount it to t equals 0, individually discount each one for the project, and then add them up. So we have minus 10 plus 20 divided by 1.1, or we could say 1 plus 10%, right? And if we wanted to be really anal about it, we could say raised to the 1. And when I do that, I get 8.18, and you should check this, right? Make sure you can do this. Great way to make sure you understand what's going on in the homework. Great way to start studying for exam 2. Okay, and for NPV-B, you should also check that you agree that the NPV equation looks like this, minus 100, that's our cash flow 0. I don't have to worry about discounting that because that's already at t equals 0. And then my CF1 is 150, and I need to discount that back by 1 year. So I've got that raised to the 1, and again, you should check that we get 36.36 when you go ahead and work this out. So I'll do one for us in Excel just to convince you that it's true, it's really true. Okay, 36.36, same thing I got here. But what you need to do is make sure that you agree that this is the right equation and that this is the right answer. And you should do that for every numerical example that we do in class before you start on the homework, and definitely as part of your studying for exam 2. Okay, so project B, check this out. Project B maximizes our increase in wealth. Remember the increased wealth concept from the last handout? Okay, and if we pursue Project B, it makes us richer. That's what we care about, right? That's the most important thing. Which project, we can only do one of them. Which project, the right question to ask is which project is going to make us richer? So we're going to go with B, okay? NPV is the only of our 3 DCF methods that is always going to give you the right answer to this question. The question being, if we have 2 mutually exclusive projects, which one is better? NPV always gives us the right answer because it's the one that tells us which project is going to maximize our wealth more? That's the right question to ask and answer. Okay, so why did we run into trouble with BCR and IRR? The problem is neither of these methods speak to the scale of our projects. NPV is the only one that thinks about the scale of the projects. So because of that, neither one can talk about which one will make us richest, right? So if we have a very, very big project with a maybe not the highest IRR in the world compared to a very small project that may have a very high IRR, doesn't matter. The small project, even though the IRR is bigger, because it's so small, it doesn't increase our wealth as much as the bigger project. So that's what we want to be looking for. Short thing to remember, if you only want to remember one thing, is NPV is the method to use to answer the question, which mutually exclusive equal length project is best? And I'm being interrupted all over the place today, so sorry about that. Okay, let's get back in action here. All right, so let's look at another example here. Let's consider Lukoil. Lukoil has gas stations with convenience stores attached all over the country, mostly on the East Coast and West Coast now, but they're coming into the Midwest. So they're thinking about renovating one of their gas stations. They renovate their gas stations about every 10 years on average, and they, of course, clearly they can only put one station renovation at this existing location. So we're going to consider two alternatives for them here. The first one is what they call their gas plus convenience store alternative. And for this alternative, they'd have to spend a little more than $1 million now, and then they believe that their net after-tax cash flows from that gas station would be about $195,000 per year for the next 10 years. And they have another alternative. So clearly they can do one or the other here. They're not going to be able to do both. The second thing that they're considering is what they call their gas and go alternative. And that doesn't have a full convenience store. They're not going to be selling soups and sandwiches and all that stuff. They'll just have a few things like oil and washer fluid and snacks and sodas and stuff like that. So that's why it's gas and go. So that costs a lot less to do. That costs them less than $1 million, a little more than $500,000 to do the renovation. And they project, if they do that, that they'll get about $100,000 a year in net cash flows after taxes for the next 10 years. And then they're going to renovate again after 10 years. Okay, so Lukoil's been doing this kind of thing in this country for quite some time. They've been operating in this country for about 40 years. So they have about 30 years worth of good data on gas station renovations. And so based on that, they can develop their own internal opportunity cost of capital for this type of project, which they've done, and they say that they believe it's about 10%. Okay, so let's evaluate both projects with all three of our DCF methods. Here's our NPV method. Here's the fundamental NPV equation. So we'll think about that. And then let's also evaluate it with our BCR method. And here's the fundamental equation for BCR, where we put that negative cash flow absolute value of it in the denominator and all the positive cash flows after they've been discounted up in the numerator, added up together. And then for IRR, we just have our NPV equal 0 equation here, where we just take our NPV equation from up above and we set it equal to 0. And how do we set it equal to 0? We change the discount rate until we find that equation turns out to be 0. So we want to use all three methods for this. So I've done this for us already for the Gas Plus option, the Gas Plus convenience store option here, and you can check all of these if you like. But I've got to tell you, in this case, right, for this project, finding the NPR, NPV, and the BCR is going to be tedious because we have 10 years of discounting, right? So it's just going to be a lot of work on the calculator, a lot of room for mistakes, all that kind of stuff. And also finding the IRR, now we'd have to find the roots of a 10th order polynomial. That's no mean feat. So what I'm going to do with this is I'm going to solve this for us very quickly in a spreadsheet. Clearly on an exam, I can't ask you to solve something with a spreadsheet. I'm not going to give you a homework that requires you to solve something on a spreadsheet, but I want to show it to you because everybody taking this course, whether you're going on into finance or not, you really need to be fairly proficient in Excel. So this is going to illustrate for us how to solve a problem like this in Excel, but it's also going to reinforce some of the basic Excel skills that we all need in a business environment. So I'm going to be working with this HO11b Lukoil, which is posted with the handout for this section. And I'm going to find for the gas and go alternative, I want to find the NPV and the BCR, and then down here, I'm going to want to find the IRR. So let's start with the NPV and the BCR. The way I've laid this out is the way that these things are always laid out in the real world in finance. So for any given project, you put down the time here of all the cash flows for one player for this project. Again, don't confuse your participants, right? So these are going to be the cash flows to and from Lukoil. And this is the time of this cash flow, the time of this cash flow, et cetera, et cetera, et cetera. And to get the NPV, conceptually, we know it's really, really straightforward. Each cash flow, just discount it back to t equal 0. So I'm going to take this cash flow here, and down here in this row, so I've got this row here, I've got the row of time here, end of year. In each case, I've got the cash flows at those times in this row. And then down here, I'm going to have the present value of each of these cash flows. So for the $522,000 they have to spend on this project, the present value is the cash flow itself divided by 1 plus the interest rate. And I'm going to hit F4 to lock that down. You see how I've locked that down with dollar signs there? Okay, and then I raise that to how much time has elapsed till we get that cash flow? 0. So I'm going to point to B8 instead of hard coding in a 0 there and hit return, and I better get 522 because that cash flow is at t equals 0, so I discount it back to t equals 0. I better get the same thing. But now look, if I've done this right up here, I think I have a general formula, so I can just drag this formula all the way out to year 10, And I think I did that right, and I've saved myself an enormous amount of work, and I can check whether I have the right answer in two ways. So clearly the denominator is getting bigger as I go out in time here, so all these numbers should be getting smaller, which they are. And then also, if there were no time value of money, if I had 0% here, instead of 10%, then all the present values of each cash flow would be the same as the cash flow itself. So that looks good. So I think I've put this all in properly. Okay, so what's the NPV? The way we get the NPV is take every stinking cash flow for this project, for this player, right? And then add them up after you've discounted them, and that's the NPV. So I'm just going to say equal the sum of all my discounted cash flows. There we go, 92.46. And for BCR, I do something very similar. As you know, I'm going to take the sum of the present values of all the positive cash flows, put that in my numerator, and divide that by the absolute value of the sum of the present values of all my negative cash flows. I only have one in this case, so that makes it easy. Okay, and I have a positive NPV, a BCR greater than 1. That makes sense. They should be working in the same direction, and they are. So far, so good. So now let's go down to the IRR. So I've got the same thing here. I've got a row with when does a cash flow happen for Lukoil measured in years, and then the next row is the cash flow itself that happens at that time all the way out to year 10. Okay, and I'm still going to want to do something very similar to what I did with the NPV formulation, except I'm going to want to solve for the R, or the IRR more specifically here, that makes the NPV equal to 0. So what am I going to do? I'm going to start with a guess. I'm just going to guess. I don't know. I have no idea. Let's say 10%. And using that guess, I'll compute the NPV, and I'll show you how this works. So using my guess, I discount this 522 back, just like I did before. And again, I'm going to lock that down with my F4 for you Windows users, and you SADMAC users. I'm sorry, I don't know what the equivalent is. And I want to raise that to the 0, and now I think, again, I've got a general formula there. I might have a mistake, but it looks good to me, and if I put 0 in there, I get the present value of the cash flows is equal to the cash flows themselves, so that's good. So I'll put my 10% back there. So now what do I want to do for the IRR method? I just want to add up all these present values, just like the NPV method here. Okay, so I'm going to say equal sum of all these puppies. All right, there we go. And what I want is to make this NPV 0 by improving my guess on what the IRR should be. So let's try 11%. It's going down. That's good. Let's go 15%. Oops, now I got a negative number. So I'm somewhere between 11% and 15%. So I could try 13%. Now I'm positive. So I could keep going doing this myself. Or if I had a sacrificial mentee, I could ask the sacrificial mentee to do this. I'll come back into the picture now that we know what we're doing. I could say to my sacrificial mentee, keep going with this until you get to 0. And if I really want to keep my sacrificial mentee out of my hair for a long time, I could tell them to do that until we get the project NPV to 0 to 14 significant figures. That would keep them out of my hair for a long time because Excel only records numbers to 11 significant figures. So that would give me a lot of peaceful, uninterrupted work. But there's a better way to do this here, and that's to use the goal seek function in Excel. So we go to data what if analysis goal seek, and we want to say set that NPV, which is in D19, okay, to our value of 0 by changing our guess at the IRR. And blammo, we've got it not working. And this is a bug in my version of Excel on this computer, which drives me crazy. Okay, so I'm going to have to do this slightly differently here. I can use solver. I'll show you how this works. So I want to set my objective here. Solver is just a little more complicated version of goal seek. I want to set that objective to a value of 0 by changing my variable cells there. And I'm going to say solve, and let's see if that works. And that worked pretty well. That solver is just a fancier version of goal seek, and because I've got a bug in my goal seek that I can't figure out and Microsoft doesn't seem to be able to help me with, I use solver. So what you can see is if we say that the IRR is 14%, then it makes it really true that the project NPV is 0. So that's the right answer, okay? So now I have my answers for the gas and go alternative for all three here. So let's just slide this over like that so we can see them all. And you can't see me anymore, but that's fine. And let's fill in these numbers here. So what do we have for our NPV? We have 92.5, we could say, and for our BCR, we have 1.18, and for our IRR, we have 14.0%, okay? So clearly, if we were using IRR to determine which is best, we'd choose gas and go. Same for BCR, we get more bang for our buck, okay? But look, when we look at the NPV of these two projects, Gas Plus has the higher NPV. That's the one that's going to make us wealthier. Remember, we can only do one of these projects. This one makes us wealthier from the increased wealth concept, so we'd want to go with B. Okay, so just heads up, this page is in gray. If you want a more in-depth, detailed, step-by-step view of how to solve this, I've got about a 10-minute video on this at this hyperlink, which you're welcome to watch. Again, completely optional. You're not going to be tested in Excel in this class, but I do think every business student should be somewhat proficient in Excel. So here I've got my numbers typed in for us nicely. So definitely both look attractive. Like we said on the previous page, BCR and IRR suggest that gas and go is better, but NPV indicates the opposite, and Lukoil is going to choose the gas plus here because it maximizes the increased of the firm. Can only do one of these projects, so you want to always pick the one that maximizes the increased wealth of your firm. Okay, so I'll come back into the screen here. Let's put that aside. Okay, so I'm back with you now. And let's see, that looks a little better. Okay. The next thing we need to look at is what's called the payback period project evaluation method. You should know that this is not a discounted cash flow method. All right, that's why I haven't included it with our discounted cash flow methods. It does not consider time value of money. And as we know, all of our discounted cash flow methods centrally consider time value of money. So what is the payback period method? How does it work? It says very simply that the best project when we're comparing two projects is the one that recovers our costs quickest. Okay, so let's look at an example here. Which project we think is best. And we could say here, project A at t equals 0, we're going to have to spend 10 million, 10,000, whatever it is. And we believe if we do that, that we'll get 15 million back in a year, and then the project is over. So these aren't equal length, but it doesn't matter for this method. It does matter for our DCF methods. And for B, we'd have to again put in our 10 million at t equals 0. We got nothing at t equal 1, and we'd get 50 million at t equal 2. Okay, so the payback project says that A is best, and let's think about which would be best using our NPV method. So using our NPV method, we'd have minus 10 plus, what is it, 15? Okay, 15 divided by 1 plus, I think we said 10% raised to the 1. Let's see if we have, yeah, the opportunity cost of capital is 10% for both. So the payback method doesn't even need that. It just looks at these two and says that A is best because it's recovering our cost fastest. Okay, so that's the way it works that's the rule for the payback method. Okay, and for our NPV method, again, you should check, but if you look for project A, you'll see it gives us 3.63, and for project B, we have again our minus 10 plus 50 divided by 1 plus 10% raised to the 2, and you should again check that, but I get 31.3. So once again, the NPV is telling us that the project B is best, even though another method told us project A is best, right? NPV of B is bigger than A. In this case, it's fine, even though the projects are not of equal length to do this kind of analysis. I will not try to trick you with this kind of thing. So if I give you something, projects to check in this way, it's going to be okay to do that. All right, I'm not going to trick you with, oh, we can't use this method. Okay, so, but in general, when we're comparing projects using DCF methods, they will be of equal length. In this case, it's okay that they're not of equal length. All right, so which project is best? Comparing NPVs, we find that project B is best, and that would actually be the right answer in this case. So payback method is totally useless, which is usually what's taught in schools, because number one, where's number one? Number one, it doesn't include time value, and number two, it doesn't give you the right answer compared to using our comparison of NPVs. And that's generally correct, except in cases like this. What if we're a small company and we've got to borrow 10 million now to start our project? And this is a very common situation for startup companies. maybe we're not going to be able to pay interest on that 10 million for 2 years because we just got money from some venture capitalists and we're not going to have any revenue from our product and we're going to have no revenue coming in. So we can't survive for 2 years. Okay, so for us, project A is going to be not only the better one, but it's going to be the only one that we can do because we need to pay back our loans at this time. And even beyond that, we wouldn't be able to. We have no positive cash flow coming in to pay interest on this $10 million loan. So for a small startup, actually, it's true that the project that repays our costs most quickly may well be the best option and in fact the only plausible option. Okay. So that's the story for the payback method, which is another method we need to know. And I'm going to take a pause here, and when we come back, we'll continue and we'll go through project evaluation under capital rationing or capital budgeting. So let's pause it here, and we'll be right back to finish up the chapter.